Hello, I'm Chad Kay, and today I will be discussing the supercontinent Pangea. Each week I will cover a new topic. The aim of this podcast is to share fascinating facts about various subjects, all accompanied by calming, soothing music in the background. My hope is to help you unwind and enter a peaceful state of mind, or assist you in drifting off to sleep after a long day. So find a cozy spot or lie down, close your eyes if you would like, and immerse yourself in these relaxing facts. Pangea was a massive supercontinent that existed in the late Paleozoic and early Mesozoic eras. It formed around 335 million years ago from the merging of Gondwana, Euramerica, and Siberia during the Carboniferous period. Around 200 million years ago, near the end of the Triassic and start of the Jurassic period, it began to split apart. Shaped like a C, Pangea extended from the northern to the southern polar regions and was encircled by vast oceans. It is the most recent supercontinent and the first one geologists have been able to reconstruct. The idea that the continents were once joined together and later drifted apart was first proposed as early as 1596 by Abraham Ortelius. However, the theory gained scientific support when Alfred Wegener presented it in 1912 through a series of German academic articles titled The Origin of Continents. He later expanded on this theory in his 1915 book, suggesting that all current continents were once part of a single massive landmass. Wegener first used the term Pangea in the 1920 edition of his book, describing the ancient supercontinent as the Pangea of the Carboniferous period. Wegener initially suggested that Pangea broke apart due to forces from the Earth's rotation acting on the large continental masses. However, this idea was quickly dismissed as physically unrealistic, which hindered the acceptance of his hypothesis. Later, Arthur Holmes introduced a more credible explanation involving mantle convection. Combined with ocean floor mapping conducted after World War II, this led to the development and widespread acceptance of plate tectonics, a theory that now serves as the primary explanation for both the formation and breakup of Pangea. The idea that the continents were once joined together in a supercontinent called Pangea was first supported by the geography of the Atlantic Ocean's bordering continents. Observers noticed that the coastlines of South America and Africa, as well as North America and Europe, appeared to fit together closely, like pieces of a puzzle. Later, detailed studies focusing on the edges of the continental shelves at a depth of about 910 meters revealed that the gaps between them were less than 130 kilometers, or 81 miles, which was considered too precise to be just a coincidence. Pangea existed as a supercontinent for 160 million years. From its formation around 335 million years ago in the early Carboniferous to its breakup about 175 million years ago in the Middle Jurassic. During this time, significant evolutionary developments occurred. In the early Carboniferous, the oceans were populated by corals, brachiopods, bryozoans, sharks, and the first bony fish. On land, forests were home to insects, arthropods, and the earliest tetrapods. By the Middle Jurassic, when Pangea began to break apart, the seas were filled with mollusks, especially ammonites, ichthyosaurs, sharks, rays, and the first ray-finned bony fish. On land, forests of cycads and conifers dominated, providing an environment where dinosaurs thrived and the first true mammals appeared. The separation of Pangea was linked to the release of significant amounts of carbon dioxide from continental rifts, resulting in a high concentration of CO2 during the Mesozoic, which contributed to the warm climate of the early Cretaceous. Additionally, the formation of the Tethys Ocean played a role in the climate warming. The highly active mid-ocean ridges formed during Pangea's breakup caused sea levels to rise to their highest point in geological history, leading to widespread flooding of the continents. The spread of temperate climate zones that occurred with the breakup of Pangea may have played a role in the diversification of angiosperms. Pangea finally broke apart by the Middle Mesozoic era between approximately 201 million and 145 million years ago. A distinct reversal of winds resulted in extreme transitions between dry and wet periods throughout the year. The breakup could have also contributed to an increase in polar temperatures as colder waters mixed with warmer waters. The tectonics and geography of Pangea may have worsened the Permian-Triassic extinction event or other mass extinctions. For example, the reduced area of continental shelf environments may have left marine species vulnerable to extinction. However, no evidence for a species area effect has been found in more recent and better characterized portions of the geologic record. Another possibility is that reduced seafloor spreading associated with the formation of Pangea and the resulting cooling as subsidence of oceanic crust may have reduced the number of islands that could have served as refuge for marine species. Species diversity may have already been reduced prior to mass extinction events due to mingling of species possible when formerly separate continents were merged. However, there is strong evidence that climate barriers continue to separate ecological communities in different parts of Pangea. The eruptions of the Amatian traps may have eliminated South China, one of the few continental areas not merged with Pangea, as a refuge. Well, this wraps up my brief talk about Pangea for this week. If you enjoyed this episode of Relaxing Facts, please consider subscribing or leaving a comment. I hope your day is wonderful, whether you are unwinding after a busy day or just relaxing with some pleasant listening. Thank you for joining me. I am Chad K, and I look forward to seeing you next time. Bye.